So we're going to talk about the Pythagorean theorem, and the first part is understanding the vocab. So we only use Pythagorean theorem when we have what's called a right triangle. And a right triangle, how we know we have a right triangle is when we have a box here, or they might say that this is 90 degrees. Either way, box, or if they put 9, 0, that means 90 degrees. So we have a right angle. When we have a right angle, we call these sides the legs. And normally we call one the short leg and one the long leg, and you'll see why later. But it really doesn't matter, but they are both legs. And then the one opposite, the 90-degree angle, the longest side, is the hypotenuse. So right here, if I were to label this, I would say this is the hypotenuse, that's a leg, and that's a leg. Hypotenuse, cross for 90, leg, leg. Hypotenuse across for 90, the rest are legs. Hypotenuse across for 90, the rest are legs. I think you get the hang of it. So the reason why this is important is because we have a theorem. It's called Pythagorean theorem. And it says you could take the legs and square them, then add them together, and that equals the hypotenuse squared. Now, A and B, it doesn't matter which leg you plug in for A, which leg you plug in for B, but you must plug the hypotenuse in for C. Pythagorean triples, these are just numbers that if you see them, like whenever I see a 3, 4, and a 5 on the sides of a triangle, so like if I saw, it won't let me draw a right triangle, but if I saw 3, 4, and 5, I would know that that's a right triangle. So now we're going to use what's called the converse of the Pythagorean theorem, and we're going to determine whether each set of measures can be the size of a right triangle. And so when we're doing this, it's just important to make sure you let C be the biggest number. So right here I have C. C is 5. And then the other two, A and B, will be 3 and 4. And so what I'm trying to find is does 3 squared plus 4 squared, does that equal 5 squared? Well, let's see. 3 squared is 9, 4 squared is 16, 5 squared is 25. And if you take 9 plus 16, you do get 25. So I got 25 equals 25. So I would say yes. Yes. This can be the sides of a right triangle. Now number 2, if I were to do complete number 2, I would have to make C equal to 10, A and B is 5. So I'd say does 5 squared plus 5 squared, does that equal 10 squared? Some quick math, 5 squared is 25, 5 squared is 25, 10 squared is 100. And if we do 25 plus 25, we get 50, which does not equal 100. So I would say no. It's not a right triangle. Okay, and so on. Notice these are in order. 13 would be your C. Here, they're trying to trick you. C is actually your first number because hypotenuse must be the longest side. Now here, we have two legs, A and we're trying to find C. So let me draw a triangle real fast. I like having a picture. Okay, so they tell me one side is 5. That's A is 5. Call that a leg. B is 7. And they want me to find B equals 7. And they want me to find the C. So I would start off with the formula. And the formula says that A squared plus B squared equals C squared. And again, that's only true in a right triangle. But this says use the theorem to find the length of the missing third side. So, and then round to the nearest tenth. So they're telling me that, you know, find the third side that makes this the right triangle. So when I plug into this formula, A is 5. Okay, so I got 5 squared plus 7, because B is 7 squared, and that equals C squared. Doing some math, 25, that's 5 squared. 7 times 7 is 49, and that equals C squared. And then if you take 25 plus 49, you get 74. Now here's probably where kids are possibly going to get confused, because in order to solve this, to undo a square in math, we take the square root. So we're going to actually take the square root of C squared and the square root of 74. And the reason why we do that is because the square root and the square cancel. They are what we call inverses. So my answer is the square root of 74. Not that one. Square root of 74. And that's equal to C. Now, depending on the problem, they may want you to reduce that radical. But here they said round to the nearest tenth, so I would type that into my calculator, square root of 74. That's 8.6. So I get 8.60232 equals C. They said round to the nearest tenth, so I'd get rid of those numbers. I got 8.6. All right, a new one. So they want me to find a leg. I have one leg, and I have the hypotenuse. So real quick, drawing a right triangle. So we don't know A. No idea what A is. But we do know B is 8. And we know the hypotenuse is 10. And they tell me to find the leg, so we are assuming they want us to find the leg of a right triangle. I write down the formula, which is A squared plus B squared equals C squared. Now this time I don't know the A. I do know the B, that's 8. And I know the C. Again, don't know the A. 8 squared is 64. 10 squared is 100. And now what I'm going to do is I'm going to actually subtract 64 from both sides. And I'd get A squared equals, and 100 minus 64, that's 36. So again, all I did was I tried to subtract off common factors to get A squared by itself. I would then take the square root of both sides to cancel out the square, and I get A is equal to the square root of 36. Well, square root of 36 is 6. So I got A equals 6. And I could have also gotten this because 8 and 10, you go up here, this is what we call a Pythagorean triple. So anytime I see the numbers 8 and 10, with 10 being the hypotenuse, I know that the leg must be 6. So sometimes it's important, or some people do memorize some of those just to save themselves time. Find the value of each variable, round to the nearest tenth. So I know the whole thing is 10. And I know this symbol right here, which is the same as this symbol, tells me those are congruent. So if the whole thing is 10 and both of these are congruent and they add up to 10, then that tells me that each of these sides must be 5. Okay, and then instead of calling it a side, I'm going to call it a leg. I know this is a leg because of the right angle. So here's my hypotenuse. Remember, hypotenuse must be C. And then A and B doesn't matter. I'll let that be A, or you can keep it as an X, either way. And I'll let this be my B. Now, I'm going to check the Pythagorean triples because is there one where the hypotenuse is 13? Let's go look. 13, so we got 5, 12, 13. Is that what we have here? Let's see. Look, 5, 13, so this has to be 12 because it's a Pythagorean triple. And I could use a squared plus b squared is c squared, but I would finish off by saying x is 12. Because anytime you see a leg of 5 and hypotenuse of 13, you know the other one is 12. Number 10, there's nothing complicated going on. I'll let you do that one yourself. This one, once more, there's nothing complicated going on. Now let's work on a word problem. So Maria, let's say this is Maria's house. So Maria is going to start right here. Maria starts right here in her house. She leaves her house and walks north 6 blocks. Now, north, remember, north is up on a flat piece of paper. So she's going to go up 6 blocks, straight north. So straight north doesn't mean that would need to be 0 degrees. If I could get there. I had it. There we go. She goes straight north 6 blocks. She then turns. Here's Maria. She then turns and walks. She heads 8 blocks east. Remember, east is to the right. So now she's going to go 8 blocks this way. And notice that's going to be 90 degrees because you're talking about distance. So this is 8 until she reaches Sally's house. And I already found Sally's house here. Just a random image off the internet. There's Sally's house. Now she's at Sally's house. What is the shortest distance between Sally's house and Maria's house? Now the reason why Maria didn't just walk this way is because normally there's trees, there's other houses in the way. You know, most city blocks work up and down, left and right. And so this is probably the only way to get to her house. But if she was able to like cut through people's yards, how far is she really from Sally's house? And so we're really just asking what's the hypotenuse. And we know that this is 90 degrees because we walk straight north, straight east. And when you're walking straight north, straight east, that makes 90 degrees because there's only 4 directions and all of them add up to 360. 360 divided by 4 is 90 degrees. So I would say A is my 6, B is my 8, and I could have gone B is 6, A is 8, but this one has to be C, the hypotenuse. I would then work it out. So I know A squared plus B squared equals C squared. And then I would plug in, what's A? 6. What's B? 8. And we don't know C. Let's see, 6 squared is 36, 8 squared is 64, 36 plus 64 is 100. Oops, I have to go backwards, hold on. So 100 equals C squared, and then I would take the square root of both sides. Cancel out the square and the square root, and I get C is 10. So I would type in a sentence and say Sally and Maria are, they talked about distance and blocks, so I guess you could, I wouldn't call those blocks, I would maybe say you are 10 units away. Now, I could have also done this a different way. Anytime I have the number 6 and 8, I know the hypotenuse is 10. And the reason why I know it's 10 is because, again, this is a Pythagorean triple. You have two legs, one's 6, one's 8. The hypotenuse must be 10. Okay, I don't want to do every single problem. I'm going to skip 13. You could do 13 yourself. 14. Find the perimeter of a square with a diagonal of 10 centimeters. Do I have a square button? Let's say that's a square. It doesn't look very squarish. I'll just rough guess it. It's okay, there's a square. And they tell you the diagonal. So diagonal from one spot to the other is 10 centimeters. Find the perimeter. Perimeter is distance around the outside. One thing I could do is remember that one property of a square is that all sides are the same. That's one very important property. Another important property is that all corners are 90 degrees. Now we'll talk about this later, but the diagonal actually cuts that into two 45-degree angles. So I'm just going to look at this part right here, and I'm going to let this be my A, and that be my B. We'll let that be my C. Remember, C must be across for 90 degrees. So I set up my equation. Got A squared plus B squared equals C squared. I don't know A, so I keep that as A. But I know C is 10. Now there's no way to solve this when I have one equation with two variables. But I might, realize, wait a minute. These are always going to be the same because it's a square. So really, A will equal B because it's a square. So what that means is I could go up here and I could change one of these B's to an A, or I could have changed the other B to a B. But now I have this equation that I could solve. And A squared plus A squared is 2A squared. And 10 squared is 100. I would then divide by 2. 100 divided by 2 is 50. And finally, I would take the square root. Square root cancels out the square. Now I'm going to need a calculator for this. Square root of 50 is 7. It says round to the nearest tenth. It's 7.07106. Nearest tenth would be 7.0, but because of the 7, I round that to 1. A is 7.1. All right, so I found this is 7.1. That's 7.1. That's 7.1. And that's 7.1. So the perimeter is distance around the outside. So I would add 7.1 4 times. Or I could just multiply by 4. That does the same thing. And 7.1 times 4 is 28.4. So I can say the perimeter equals 28.4. Now we'll learn later in a square there's a shortcut. And the shortcut is that I could just take the hypotenuse and divide it by square root of 2. And that will always give me the leg, which is the same on either side. But for now, this is how we're going. So the city planning committee, they're talking about making a bike path, and they only have like a little over a $5,000 budget for this project. And the cost to construct the path is a little over $2 per foot. And the path would be a straight line from the fountain to the oak tree. And so it's hard to measure this distance, but they do know that this way is 2,112 feet, and straight north is 880 feet. So how much will the path cost? Well, first I need to figure out how many feet this is. So I'm going to use Pythagorean theorem, and I'm going to let that be my C. And A and B doesn't matter. I'll just let that be A, and let that be B. And again, my formula is A squared plus B squared equals C squared. Now A is 880. B, 2,112. And we don't know what the C is. I'm going to need a calculator for this. 880 squared. And I'm going to go ahead and just type in a calculator since they're all on one side anyway. I'm going to type all of that in at once just to save time. So 880 squared plus 2,112 squared is, wow, 52,34944. Now, luckily that equals C squared. I can make that number go down a little bit. And the way I'm going to do that is I'm going to take the square root of both sides. Some kids stop here, but that's the value of C squared. I got to take the square root to get rid of the square. So I type this in my calculator, the square root of, well, how many was that? 5 million or something like that. 5,234,944, 2,288. And that equals my C. All right. Well, the cost to so this is how many feet this is. So this is 2,288 feet from here to here. But the cost to construct the path is $220 a foot. Well, I know how many feet it is now, so I would take that times 220, and this is going to be the cost. We'll take that times 2.2, and I get $5,033.60. Now, what was my budget? My budget was $5,050. I'm only going to spend 5,033. I came pretty close. So I would say the project would cost $5,033.60, which is less than the uh, proposed 5,050 budget. All right, so I always try to keep my videos under 30 minutes. And you can see I did skip quite a few problems on purpose. So feel free to finish the rest. A problem very similar to what we just did here with the bird feeder. You want to put fence around your large yard. They each give you a quote, and the boundary of your yard is determined by 5 trees, and the lines connecting them form the edge of your property. Is what you're going to do is you're going to plot your 5 trees here, and I went ahead and plotted the first 2 trees for you, and you're going to let each space be 10 foot by 10 foot, and you're going to go through all these steps. And so again, the first 2 trees are here. You're going to fill in the other trees. Notice right here, if I wanted to find the distance from T1 to T2, I know that this distance is 1, 2, 3, 4, 5, 6. And this distance is 1, 2, 3, 4, 5, 6, 7. So in case you can't visualize it, this does make a right triangle. And you would need to count the units to find the hypotenuse. And so you're going to show the work from tree 1 to tree 2, which is already drawn for you, and for all the other trees. And then you're going to compare the cost of 2 companies. And which company would you pick? So good luck to you. Let me know if you need help. Have a good day.